Hello, Algebra 2 students. It's your math teacher, Mr. Murphy, coming to you from our classroom 122 at Oshkosh North High School. Today, we're going to get you ready for your mid-chapter 3 test, and we've got this mid-chapter 3 review worksheet for you that we're going to take a look at. Now, I'm going to go through and do each of these questions. Feel free to try them first on your own, and then you can always stop the video and try them and then come back to check to see how you did. So there are 9 questions on this mid-chapter review. Let's start with the first one. A car is bought new at $32,500. Its value depreciates at 15% each year. How much will it be worth in 8 years? So when you look through, you're looking for, you look for numbers, obviously. Numbers like 32,500, 15%, 8 years. The numbers are going to be part of the situation. But you're also looking for critical descriptive words. And in this case, depreciates is going to make a big impact on this question. So our formula is y equals a times b to the x, where b is 1 plus or minus the rate as a decimal. Now, the decimal is 15%, that'd be 0.15. Decimal is 0.15. We have to decide if we're going to add that to 1 or if we're going to subtract it from 1. We would add it if it appreciates or gains value, but in this case, it depreciates or loses value. So we're going to subtract the 0.15 from the 1 when we do this. So let's get this set up. Let's go with y equals, A is the amount, $32,500, times B, which is, in this case, it's going to be 1 minus 0.15, so 0.85. And then times x, which is the term, the number of years, which is 8. All right, at this point, it becomes a calculator exercise. Do your exponent first, so 0.85 to the 8th, and then take that times $3,200 or $32,500, and you will get $8,855.94. So that was your first one. That's how much the car is worth after 8 years. Next, we're going to solve a system of equations. Now, when it says system, it means more than one equation at a time. So we have, in this case, we have 2 equations and 2 variables. In order to solve them, we need to get it to 1 equation and 1 variable. Here's a key vocabulary term that they brought up. They wanted their answers in ordered pairs. So that means the x comma y. All right, well, when you're doing a system of equations, you have a couple of choices. One of your methods, which is the least accurate, is to graph. Your second method that you learned would have been your substitution, and your third method would have been your elimination. In this instance, we're looking at a substitution because it says the x equals 2y plus 5. So we're going to take this expression 2y plus 5 and substitute it into the first equation in place of x. So I'm going to rewrite the first equation, but instead of that x, we're going to put 2y plus 5 because that's the substitution as indicated in the second equation. So then it's minus 4y equals 17. So that'd be 6y plus 15 minus 4y equals 17, which is 2y plus 15 equals 17. So 2y equals 2, and therefore y equals 1. Now that's a lot of work, and a lot of times that's all you do when you're done. That's the final answer. But in this case, that's just the answer for y. We also need the answer for x. So let's go back to this equation where it was x equals 2y plus 5. But instead of y now, I know that y is 1. So it's 2 times 1 plus 5. So x is going to equal 2 plus 5, or 7. So now we're going to write this as an ordered pair, 7 comma 1. And that'll be our final answer as an ordered pair. It always helps to check your answers before you move on to the next question. So let's check your answer here. If we put 7 in for x and 1 in for y, does it work for both equations? It should be an answer that works for both. So let's see. 3 times 7 is 21. Minus 4 times 1 is minus 4. 21 minus 4 is 17. That does check out. How about in this instance? If x is 7, 7 equals 2 times 1, which is 2 plus 5. 7 equals 2 plus 5. Yep, that checks out. So we know that we got that one right. All right, moving on to number 3. This is going to be the elimination. And there's 2 different ways you can do it. I'd usually suggest go with the easier way, which is just multiply one equation if you can. But if we add these together, we don't have any variables dropping out or zeroing out. The goal is when you have 2 equations, it's to eliminate a variable, is to get a situation where you can add the 2 equations together and one of the terms becomes a big 0 and you just have one variable left and you can solve that. We're not so fortunate in this case because if you add these together, you're going to get 2x, you're going to get 1y, you're going to get 3. So it's going to be one equation and 2 variables, which is unsolvable. So we could eliminate the x by multiplying the top equation by 3 and the bottom equation by 2. That would get us negative 12x, and that would get us 12x adds up to 0. But let's get rid of the y because we got 2y here, we got negative 1y here. And if we multiply this equation by 2, we can get a situation where the 2 equations will add up and we'll be able to eliminate the y. So we get 12x minus 2y equals negative 22. Now let's bring the top equation down. Negative 4x plus 2y equals 14. And I'm going to rewrite this equivalent equation here. 12x minus 2y equals negative 22. Now when we add these 2 equations together, we get 8x. There's your big 0 right there. That adds up to 0. And you get equals negative 8. Divide by 8 and you get x equals negative 1. So that's the answer for x. In order to determine the answer for y, you can substitute negative 1 in for x into either of these equations. I'm just going to select the top one for you. So it's negative 4 times negative 1 plus 2y equals 14. That's 4 plus 2y equals 14. So 2y equals 10 and y would equal 5. As an ordered pair, our answer is negative 1, 5. Well, let's check mentally and see if that works. So if we put negative 1 in for x, negative 4 times negative 1 is 4, and 2 times 5 is 10. 4 plus 10 is 14. How about the bottom equation? 6 times negative 1 is negative 6. Minus 5 is negative 11. Yep, that checks out. So we're good to go. So that's it for number 3. There's 9 of these total, my friends. Next, we're taking a look at factoring. Factor each expression completely. Now, that word completely indicates that there might be a situation where we have more than one factoring technique. You're going to find that sometimes you have to factor out the greatest common factor before you can start with your Box-Diamond methods. So let's see if there's a common factor in this equation. Between 3, 17, and 6, is there any number that will divide into 3, 17, and 6? No, there is not. So in this case, factor completely means just factor. So let's factor it out. So this is our diamond. I just did the x. I didn't really make the whole diamond. But 3x squared times negative 6, multiply them together. That goes in the top. The middle number goes in the bottom. So you're looking now to put numbers on the sides. They have to multiply to get negative 18x squared and add to get 17x. So let's go with negative 1x and 18x. They multiply to get negative 18x squared, and they add to get 17x. Now we can do our rectangle. And you start with the 3x squared and the minus 6, and they match up diagonally. Then for these other 2 boxes, we're going to put in these 2 numbers. So let's go with negative 1x there. Let's go with 18x here. All right, so now we're going to figure out the answer. So 3x times x is 3x squared. 3x times 6 is 18x. X times negative 1 is negative 1x. And the way to check it is these 2 at the end should multiply to get you this box. Negative 1 and 6 multiplies to get you negative 6, so that does check. So now we can verify that our answer is 3x minus 1, which is on this side, times the bottom x plus 6. And that is the factored form, my friends, and the answer to number 4. Let's take a look at number 5. Remember, it said factor completely, so perhaps this is the question that's going to have a greatest common factor to factor out. And it does. What goes into 2x squared, negative 20x, and positive 50? Well, they're all even numbers, so they're all divisible by 2. So we could take out the number 2, or divide out the number 2. So we'd get x squared minus 10x plus 25. Let's just check to make sure we did our math right. 2 times x squared is 2x squared. 2 times negative 10x is negative 20x. 2 times 25 is 50. So we're good. So now this 2 is going to be part of our final answer. But in order to factor this part, let's ignore the 2 for the time being. So let's take a look at this and put it into the diamond. So you got your 25x squared and your minus 10x. Those numbers. Multiply this times this goes here. This number goes there. We need two numbers that multiplied get us 25x squared and add to get us negative 10x. And the only combination that works will be negative 5x and negative 5x. So it's time for our box, and we establish that, and we put our x squared in here, and we have our 25 there. And don't forget, at the end, we're going to have to put this 2 in there. It's easy to forget that, but we'll put that in at the end. So what goes in these two boxes, you get that from here. Negative 5x, negative 5x. All right, now let's figure out the rest of it. X times x is x squared. X times negative 5 is negative 5x. X times negative 5 is negative 5x there. And negative 5 times negative 5 indeed is 25. So we're ready to write our final answer. Now we got to remember that 2 was part of the answer. And then we have x minus 5 and x minus 5 for this and this. Now, sometimes it's cool to write it this way, x minus 5 squared, because after all, there's 2 of them there. That's probably the best way to do it. Either way is fine for your test coming up after you have studied. So that concludes number 5. We're now going to move into simplifying radicals in number 6. Now I've made a perfect square chart for you here. And the reason why you have to know those is because if you're simplifying a radical, you're going to divide out a perfect square radical in order to simplify it. Basically, it just means to reduce it. We're going to reduce it to what they consider to be lowest terms. So we're going to start with the 80. Now we're looking for a number that goes into 80, and actually you're going to find that there's more than one. And whenever there's more than one, you want to take the highest one. In this case, 4 and 16 both go into 80. If you don't know, just try your calculator, divide 80 by the number and see if it works. So let's take the 16 because that's the larger of the numbers. So we're going to have the square root of 16 times the square root of 5, because that's how you get 80, 16 times 5, times, now we're ready for a variable. And you need to pick the next lowest even number, because when you do a square root, you need even numbers for it to work out. So this is going to be x to the 6th, but we can't forget that we're leaving out an x, so there's x to the 1st there. X to the 6th times x to the 1st is x to the 7th. And then y to the 6th, y is already an even number with the 6, so let's just keep it that way. All right, well, we're going to simplify. The square root of 16 is 4, and then we have times square root of 5. The square root of x to the 6th is x to the 3rd. You essentially just divide the 6 by 2, 6 divided by 2. There's an implied 2 to be out here outside of all the square roots. So 6 divided by 2 would be the 3. Then we've got our x to the 1st. And then we have y to the 6th divided by 2 is y to the 3rd outside the radical. At this point, we're going to group them, my friends, and put the numbers that are outside the radical together and the numbers that are inside the radical separately. And there'd be little time symbols in between all these, but you don't really need to do that because it's implied to be there. So I don't know if you feel as though this looks any simpler than that. It is considered simplest form because you've reduced some of the things outside of the radical. All right, well, you're probably wondering why I went all the way up to 144 for this. Well, that's for the next one. This one with radical 288, you're going to find that there are some different numbers that work for this one, but you want the largest perfect square number, which is going to be 144. 144 is a perfect square, and 144 times 2 is 288. So that's how you separate that. Then we have x to the fifth, and we got to write that as x to the fourth times x to the first, because we need to have even numbers to reduce. Then we have y to the third. Well, we're going to write that as y to the second times y to the first. So we're just rewriting it as an equivalent expression. At this point, Math Amigos, we are going to simplify anything that we can simplify. So square root of 144, that simplifies to 12. The square root of 2 does not simplify. Square root of x to the fourth does. That's going to be x to the second. Square root of x does not simplify out, so that's just x. Then the square root of y squared is y, and then we have the square root of y to the first, or just y. Oh, let's put y in the answer. All right, it's at the point where we combine the like terms, so to speak. Anything that's outside of the radical goes to the left, and anything that is inside the radical, in this case 2xy, goes in the radical, and that, my friends, is the answer. That is considered to be simplified at that point. And that brings us to the last two on the page. So this one says, rewrite the equation in a simpler form and then solve for x. They have some fractions here. So what we're going to do is we're going to change them all so they have the same denominator. The denominator of 6 will work because there's a 2 and a 3. So I'm going to change them all to sixth. All right, so converting 1/2 to 6, you're timesing the 2 by 3, so times the 1 by 3, you get 3. The 3 times 2 would get you 6, so you take 2 times the numerator, that's 2x. The 2 times 3 is 6, so the numerator times 3 is 15. So you get a situation like that. Now at that point, we're going to multiply by the denominator, because what's going to happen is it's going to cancel out. I'm going to write it down. I'm going to show you the whole thing. Don't worry, we're not leaving out any steps here. We're multiplying every single term by 6. That's what that means there. 15, 6 times 6. All right, so cancel, 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 and we get 3 plus 2x equals 15. Let's move it up to where we have a little bit more room. 3 plus 2x equals 15. So we're going to subtract 3, and we get 2x equals 12, and then we divide by 2, and we get x equals 6. So 6 would be our answer. Let's just check that. So 1/2 plus 6 over 3 would be 2. 5 halves, or 5 over 2 is 2.5. So 1/2 plus 2, that does equal 2.5. So indeed, that checks out. X equals 6 is the answer.